Let's hear it for multiplicative equations, part 3. Sparkle, sparkle. All right, so let's use multiplication comparisons to compare things in this picture. All right, give a look around, see if you can see any ways to use multiplication comparisons that are in this picture. There are a lot of things. It's a lot. So I'll give you an example. The number of chairs is 4 times as many as the number of tables. So for every table, there are 4 chairs. Table, chair, 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 chair. Table, chair, 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 chair. So the number of chairs is 4 times as many as the number of tables. See anything else? I see another one. The number of cups is 6 times as many as the number of napkin dispensers. Next to every napkin dispenser is 6 cups. 1, 2, 3, 4, 5, 6. Napkin dispenser, 6 cups. 6 cups. Oh yeah, I'm good at this game. All right, that's enough. Multiplication equations as comparisons, but this time we're going to use word problems. Melanie has 4 books. Mr. Smallwood has 5 times as many books. How do we represent that amount of books Mr. Smallwood has as an equation? All right, well, let's take it piece by piece like we did in the last video and just talk about the things that we know. We know Melanie has 4 books, so I'm going to write Melanie equals 4. We also know that Mr. Smallwood has 5 times as many books. So Mr. Smallwood is 5 times more than Melanie. The number of books that Mr. Smallwood has is 5 times more than the books that Melanie has. Okay, so now we're just going to replace what we know. We know that Melanie has 4 books. So if I go back to my equation here, I can replace Melanie with 4. So let's do that. Smallwood, which is S, is 5 times more than 4 because we said Melanie has 4 books. So S is 5 times more than 4. So if we were to model it, it would look like this. Melanie has 4 books, but Mr. Smallwood has 1, 2, 3, 4, 5 times as many, which in this situation is 20. Mr. Smallwood has 20 books. Let's do another one. Pencils. Zakai has 3 pencils. Richard has 6 times as many pencils as Zakai. How do we represent the amount of pencils Richard has as an equation? Again, take it step by step. So the first thing here, Zakai has 3 pencils. All right. Boom. Now, Richard has 6 times as many pencils as Zakai. So we got to say Richard equals 6 times more than Zakai. Okay, let's put it all together. We're going to replace what we know about Zakai in this equation. So what can we write? Richard, or R, is 6 times more than 3 because Zakai equals 3. So R equals 6 times 3. If we were to model it, we know Zakai has 3 pencils, but Richard has 1, 2, 3, 4, 5, 6 times more. So that'd be a total of 18 pencils. This is going well. Sonic ran 12 miles at soccer practice. Sonic ran 3 times as many miles as Mario. What equation represents the number of miles that Mario ran? We know Sonic ran 12 miles. Sonic equals 12. We also know that Sonic ran 3 times as many as Mario. So we got to write Sonic ran, or Sonic equals 3 times more than Mario. See what we did there? Notice both of my equations start with Sonic because both of the sentences tell me something about Sonic. So now I need to replace what I know. What do I know? I know that Sonic equals 12. Sonic ran 12 miles. So down here where I see Sonic, I need to replace that with 12. So 12 is 3 times more than what Mario ran. So we can't multiply here, but we can do the inverse operation of multiplication to undo this. And what's the inverse operation of multiplication? division. So we have 3 groups, and we're splitting up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew. That means Mario ran 4 miles at soccer practice, because here's the 4 miles that Mario ran, but Sonic ran 1, 2, 3 times more than that, which is 12.